Bismillahirrahmanirrahim. This is Muhammad Tayyab, and today I'm going to talk about my final year project, which is titled as Optimized Design and Development of a Three-Phase Induction Motor for Irrigation Pumps. This is a project of two people. One is I, and my group mate is engineer Mr. Faizan Faiz. Now, before starting our project, I would like to thank my esteemed Dr. Supervisor Dr. Qasim Ali and co-supervisor Engineer Umar Andava to their invaluable guidance and support during our project to accomplish our aims and objectives. Now, here is the outline of our project. Firstly, we will be talking about the introduction of project, problem statement, aims and objectives, Gantt chart, and so on. Now, here is the introduction part of our project. We basically targeted the agriculture sector in Pakistan, as agriculture sector in Pakistan is less efficient due to usage of traditional induction motors. As we know that the traditional induction motors are less efficient. They consume almost 65% of power, and therefore, the overall operational cost of induction motor is much higher than as compared to energy efficient design and development of induction motors. So, as mentioned in the PPT, in the first line, electric motors for irrigation pumps have been receiving increased attention in the agriculture sectors due to increased energy cost, scarcity of water, and the need for a more efficient irrigation solution. Optimizing motor efficiency has become critical nowadays. In over a year, an energy efficient motor can save substantial amount of electricity and reduce operational costs for farmers. Now, there are several motors which may be used in the agriculture sector in any country. Here we mention two type of motor: permanent magnet synchronous motor and induction motor. BLDC motor are also nowadays are also being used, but we are targeted induction motor, and we increased the efficiency of traditional induction motor. Here is our problem statement. What is the problem statement? Traditional induction motors are less efficient. They consume almost 65% of the total power. The yearly running cost of an induction motor is 5 to 6 times its purchasing cost. High energy consumption leads to increased operational costs, limited lifespan, and frequent maintenance requirements. Environmental impact due to higher energy usage and inefficiency. Now, these all points will directly hit one point, which is traditional induction motors are less efficient, and we need to increase its efficiency. All right. Now, here is our aims and objectives. What we did in this project, we basically increased the efficiency of the induction motor. Design and in the second point, design an energy efficient motor in ANSYS Maxwell software to improve overall efficiency. Implement optimization techniques such as genetic algorithm to enhance motor performance. Conduct a comprehensive analysis and simulation of the motor design to validate improvements. All right. So here are our aims and objectives. We did all the things during our project. Now here is Gantt chart of our project. Uh, the tasks are being divided into uh, eight tasks. Firstly, we are having our literature review, proposal defense, simulation software, and so on. Now here is our literature review. Three-phase induction motor is widely used as driving power in most of the industries, and it consumes almost 65% of the total power. This is mentioned in paper 1. The main objective of this work is application of a new architecture of a genetic algorithms to the induction machine design in order to improve their performance. Multi-objective design of high efficiency induction motor using an analytical methods. Paper 4 and 5, design modeling and analyzing of dual rotor axial flux induction motor. In the paper 6 it is mentioned. All right. Now here comes the most important part of our project, what we did in ANSYS Maxwell. In methodology section, firstly I'm going to tell you about the ANSYS Maxwell software, because we did our simulation part in ANSYS Maxwell software. So the ANSYS Maxwell software is basically a software which will help us to analyze the electrical behavior of electrical machines. All right, here you can see, as it is also mentioned in here, Ansys Maxwell is an electromagnetic field solver for electrical machine. All right, it is a powerful tool, and using this software we can analyze the electrical behavior of electrical machines as simply. In our project, we firstly targeted a benchmark motor, which is a Siemens three-phase induction motor. As the data sheet of Siemens three-phase induction motor is mentioned here, we firstly designed this motor in the Ansys Maxwell software, and then we increased the efficiency of this Siemens three-phase induction motor so that we will get a more optimized and efficient motor. All right, now here you can see we are having our rated power, which is 750 watt. Rated speed is 1395 rpm. Rated torque is 5.1 newton meter. All right, and all the parameters are mentioned here. So this is our design parameter of the motor. We firstly design this motor in Ansys Maxwell software, in which uh, the rated output power of our motor is 750 watt, speed is 1500 rpm, outer-stated diameter is not greater than equal to 125 millimeter, stack leg is also not greater than equal to 70 millimeter. All right, so we designed this motor firstly in the Ansys Maxwell software, and then we improved its efficiency. So here you can see these all are our variables. Now in three-phase induction motors, we are having two types of variables. First one is dependent variables, and second one is independent variables. Now the dependent variables are dependent into independent variables. All right. Now these all variables are independent variables. For example, the output power is independent variable, which is fixed, which is 750 watt. All right. Speed is 1500 rpm. It is also fixed, and which is why we can say this is also our independent variable. Outer stated diameter is also not greater than equal to 125 millimeter. We can say that it is our independent variable. All right, so these all are our design variables. We used these variables during our project. Now here is quick mesh analysis of our project. So the mesh analysis basically helps to check the electrical fields inside the motor. All right. Now here are the results and the discussions which we got during our project. Now here is the first result. As you can see, in the horizontal line we are having time, and in the y-axis we are having values of currents in ampere. All right, so this is our value of current, which is equal to average value of RMS current, which is 1.76 ampere. Okay, so this is the amount of current which we also which is also mentioned in a Siemens three-phase induction motor. So we designed our Siemens phase induction motor in Ansys software, and we got this value of current. And here is our torque value, which is 5.1 newton meter. This is average value of our torque. And here is our speed in rpm, which is 1386 rpm, average value of our speed. And here is our output power, which is 750.3 watt. And here is our efficiency before optimization. The efficiency is 71.54 percentage. Okay, now this is all the requirements of our benchmark motor. The benchmark motor is Siemens three-phase induction motor, and we got the efficiency which is also mentioned in the parameters of a Siemens three-phase induction motor as well. So we need to increase the efficiency of this by applying some optimization technique, for example, genetic algorithm, particle swarm algorithm, water cycle algorithm, and so on. But in RFIP, we used genetic algorithm to increase its efficiency. Now here we started with our optimization part. So in Ansys Maxwell software, we are having an option which is Optometrics in Ansys Maxwell. Inside the Optometrics, we are having uh, four to six sub parts, out of which C part is optimization. So doing the optimization, firstly, we need to set the variables for optimization, which are going to directly participate in the optimization of the motor, and will going to increase the efficiency of the motor. All right. And in the optimization section, we are having multiple optimizers. For example, non-linear sequential algorithm, genetic algorithm, and we are having some more optimizers, but we choose genetic algorithm as our optimizer because it is simple, and genetic algorithm is not restricted to two or three variables. It is, more beneficial for us because it will directly uh, increase our efficiency, and reduce the overall cost of the induction motor. Now here are our targeted value. These values are chosen. They are basically they basically participate uh, in the efficiency, in the improvement efficiency of the motor. Now the number of rotor slots is NS is the number of stator slots, NTC1 is the number of the turns in the stator winding. All right, and we are having the minimum value is 20 in the case of number of rotor slots, and the maximum value is 30. Minimum step is 1, and the maximum step is 2. All right. Now here is our efficiency. As you can see, we need to increase the amount of efficiency, so which is why our condition is maximized, and we used as optimizer as our genetic algorithm. So after optimization, we got these results. uh, uh, we modeled 20 different model in Ansys Maxwell software, and finally we got this high efficiency model, which you can see the number of rotor slots is 24, the number of stator slots is 40, and the number of turns in the stator winding is 95. All right. So in this case, we will get 77.33 percentage efficiency. So this is our aim, and we did this in Ansys Maxwell software. Now here is a comparison graph, comparison results of our motor before optimization and after optimization. So efficiency is 72 percentage before optimization. After optimization, it is 77 percentage. Other variables are not 10 or maybe slightly changed. Torque is 5.1 before optimization, after 5.28. Current is 1.77, and after optimization it is 1.74, and so on. Here is the hardware part. As making the hardware of our three-phase induction motor, uh, in our country, in Pakistan, we didn't find the exact size of disk to which we can build our hardware. So it is important to understand that making the hardware of a three-phase induction motor requires a disk with the same size diameter that the motor has. In our case, the outer stator diameter is 125 millimeter, which is why we need a disk of 125 millimeter. We require a disk of 125 millimeter dia, which will form our motor stator and rotor cores part. Unfortunately, in Pakistan, we don't have any technique to build any size of three-phase induction motor. Local motors are available in specific diameter sizes only. So, uh, sourcing and initial modification, we discussed this fact with our supervisor and found a Siemens three-phase induction motor in a local mechanic shop named AC Car Washers. The process included dismantling and preparing the motor for winding and other necessary adjustment. Now here is the image of our three-phase induction motor. We uh, got this from AC mechanic shop, and here is the winding which we did uh, during the hardware part of our project. And here is the coupled with pump. Our motor is coupled with pump. Here we faces one challenge because our pump the shaft diameter and our motor diameter, shaft diameter, uh, was not same at the moment. So we did welding and then we joined these two, and here is the coupling, as you can see. And this is the block diagram of our hardware. Firstly, we are having our three-phase supply, and then the three-phase supply, for measuring purpose, we need to measure voltage, value of voltage and current, which is why we connected the output of three-phase supply to power measuring unit, and then the output of three power measuring unit will be connected to three-phase induction motor. So here is a hardware connection, physical hardware connection of our induction, of our three-phase induction motor. As you can see, this is our three-phase supply, and this is our power measuring unit. This is our three-phase induction motor, and we used this three-phase induction motor for irrigation purposes, which is why we are having a small setup of irrigation systems as well. Now, finally, we also built one website for our project as well. The purpose of making this website is to publish our work in internet. For example, in on GitHub, on any other platform, so that maximum number of people visit our project. And here is conclusion. In conclusion section, we can say that significant efficiency improvement in the Siemens three-phase induction motor design. Successful optimization of motor design variable using genetic algorithm achieved higher efficiency, reduced operation cost through enhanced energy efficiency. Future recommendation from our side: apply other optimization technique rather than genetic algorithm, use other motor rather than Siemens three-phase induction motor, investigate the use of alternative materials for stator and rotor cores to further enhance performance, conduct real-world testing to validate simulation results, and refine the motor design based on empirical data. So here are our references, and thank you so much to all of you for listening, and do subscribe Sakkara IBA University channel. Thank you so much.